In the present video, I'm going to demonstrate for you additional examples of parametric and polar plots using the plotxy plugin and the snippet that we developed or that we downloaded actually in a previous video. So we start by opening up our SMA Studio file with the examples pre-programmed. I have already written out the names of the equations and the name of the functions used to produce the plots with the corresponding graphs. You know how to do that. What is missing here is the insertion of the snippet. We're going to go into Tools, Snippet Manager, and basically what I need is S&G functions. Remember, the S&G information is informational only, and we're not going to use it in this case. We're just going to insert the S&G function. We insert it right here, and we type stats. It's as you can see here, it's still working on the calculations after I inserted the snippet, so it won't let me type anything until it's done. I'm going to put a pause here and come back when it's done. All right, well, now we can type the things in here. We click on the line and type graph. For some reason it's not giving me, let's just type G and S for S&G functions. Anyway, the important thing is that once I insert that, all my functions start operating, and I'm going to show you here a polar graph of this function, which is a cardioid, generating the data using M1, and then I type M1 here, and I get my cardioid. If I change to this particular function with a negative sign and changing the size of my grid, I can get another different cardioid. Here I'm generating a grid of a polar grid and plotting the function f of theta equals theta, which is a spiral, and putting together my grid mg and my plot and my p. Here are some other examples of polar plots. A cardioid, this 8-figure, and the spiral. If I create an object here, which is simply a brace, basically what I did is type obj, which is object equal, and then click on the brace, add one more element to it, and then start typing the names of the files, of the data files. And once again, as recalculating everything, they're going to pause, and I come back to delete that when it's done. I was able to delete that example I was showing you, but now it's again recalculating because I have a lot of graphics in here. And so let me pause again and come back to you. So here we generated 3 independent polar plots, and now we put them all together by using this object. And I have changed the coloring and the size of the components. And so the cardioid shows in green, the H-shaped figure shows in magenta, and the spiral is not visible very well, but it's a orange color. I put a label here with I'm listing only one element. So let me fix that. If we double click here and I go to legend, and we're going to check on the traces, make sure they all have names. That's what happened. Well, trace 1 and 2 are actually part of the grid. This is the one that's called cardioid. Okay, so somehow I lost the name of the second graphic, which is like the 8 shape. I'm going to call it 8 simply. And actually that was the spiral. Let me see. I got to the last one. And that was like the spiral, the lemniscata. Anyway, when I redid this, I messed up the legend, but the idea is that you can increase the size of your graph, or even change the grid to show your legend to the left, as in this case, and actually change the grid so you have shows more of the grid. And here we have some example of parametric plots, F1 and F2. One very common type of parametric plots, the so-called Lisajous figures, which are a combination of sine and cosine functions with different amplitudes and the magnitude of the angles here. And so with the same magnitude and the same values of k, you get a circle. Oops, sorry. But you can change the shape you get by changing some of the values, like k1 k equal 2 produces a parabola, and then there's this form here that you get like in a oscilloscope, and you can see how you can change the parameters and produce different Lisajous figures. Some other parametric plots, you have this, it's kind of a cycloid, then you have this shape and this cardioid, and like a double cardioid, a triple cardioid, a cardioid with a circle, and some other figures, but just changing the values of the parameters in the generic function there. These are figures similar to the ones that you will do with a spirograph. And there's the very last one. Again, you can go through the video and try to repeat the figures. I just want to show you what you can do. These are the generic equations for these parametric equations, and here are other cases. And then there's the Lisajous figures. You have these generic equations. With that, we finish this particular video.